if you look at the news today, the explosion of artificial intelligence,
Yeah.
it kind of feels like a chaotic storm of unpredictable innovation.
Oh, absolutely.
You see like a new language model here, a breakthrough in robotics there, and it just feels like weather washing over us.
Yeah. But it isn't weather. I mean, it's architecture. And today we are looking at the blueprints. We're examining the life and the mind of John McCarthy.
Right, we're doing a deep dive into this incredibly comprehensive biographical article.
Right.
And it shows how one single person didn't just, name artificial intelligence.
Which is huge on its own.
Right. But he also invented its foundational programming language, predicted cloud computing back in the 1960s, and then turned around and passionately argued that a simple mechanical thermostat has beliefs.
It's a lot to take in.
Yeah, it really is. So, okay, let's unpack this.
Well, to really understand the genesis of artificial intelligence, we have to look at the uniquely uncompromising mind of its founder. I mean, you don't just wake up one day and decide to teach machines how to think.
No, definitely not.
Right. You only do that if you view the entire world as a solvable system.
And McCarthy's environment was basically an incubator for that kind of system-level thinking. He was born in Boston in 1927.
Yep.
His father was an Irish immigrant, his mother was a Lithuanian Jewish immigrant, and both were actually really active members of the Communist Party during the 1930s.
Which is an important detail.
Yeah, because the defining feature of his childhood wasn't just learning. It was this intense, constant encouragement to question the underlying structures of society.
Exactly. Which cultivated a mind that was driven entirely by the why behind the mechanics of the world. Like, even before high school, he became completely obsessed with science.
Because of a book, right?
Yeah, he was reading this translated Russian children's book called 100,000 Whys.
I mean, that title alone just perfectly encapsulates his entire personality.
Oh, totally. He had absolutely zero patience for the traditional, speed limits of education.
Yeah.
Because he was too busy trying to understand the fundamental rules of reality.
Which leads to my favorite detail from the source material. So, as a teenager, he casually teaches himself college-level math, just using textbooks from Caltech.
As one does?
Right. And he actually gets accepted to Caltech in 1944.
Right.
They let him skip the first 2 years of math entirely because he already knew it all.
Which is incredible.
But here's the crazy part. This brilliant mathematical prodigy gets suspended from Caltech.
Yep.
And not for failing grades, but because he completely refused to attend physical education classes.
What's fascinating here is the mechanism of that rebellion. Because this wasn't laziness, it was a conscious resource allocation problem in his brain.
Right.
He was optimizing for complex logic. And, well, jumping jacks simply didn't compute as a valuable use of his time. He just discarded any rule that didn't make structural sense to him.
It's like a kid who can successfully build a Ferrari engine from scratch in his garage, but he gets held back in school because he refuses to do jumping jacks in gym class.
That is exactly it. Now, he did eventually serve a stint in the U.S. Army, and then he was readmitted to Caltech and graduated.
Okay.
But it was there that he attended a lecture by the computer pioneer, John von Neumann, and that gave his hyperlogical mind a concrete target.
How so?
Well, von Neumann showed him that computation wasn't just this tool for calculating artillery trajectories. It was an entirely unexplored frontier of logic.
A frontier McCarthy decided to literally name, because by the mid-1950s, he's an assistant professor at Dartmouth.
Right.
And in the summer of 1956, he organizes the famous Dartmouth Conference. McCarthy, along with Marvin Minsky, Nathaniel Rochester, and Claude Shannon, they wrote the proposal that officially coined the term artificial intelligence.
He essentially planted a flag in the ground, but he recognized almost immediately that just naming the territory wasn't enough.
Because the tools weren't there yet.
Exactly. The existing programming languages were basically just digital calculators. They crunched numbers. But to build artificial intelligence, machines needed to manipulate concepts.
Right.
So in 1958, he had this massive breakthrough. He took the syntax of something called lambda calculus and created the Lisp programming language.
Okay, I want to break this down. Because lambda calculus sounds incredibly intimidating to, well, anyone who isn't a mathematician.
Fair enough.
How exactly did Lisp change the way computers actually process information?
Okay, think about early computing like a massive spreadsheet.
Okay.
It's great for adding up columns of numbers, but what if you want the computer to understand a relationship or solve a logic puzzle or learn the rules of chess?
A spreadsheet can't really do that.
Right. So McCarthy realized that if you format code as lists of symbols, using nested parentheses to group concepts together, the code can actually treat other code as data.
Wait, really? So the program can essentially rewrite itself while it's running?
Precisely. It allows for recursion. That's where a function can call itself over and over to solve smaller and smaller pieces of a problem.
Oh, wow.
Yeah, Lisp didn't just instruct the machine. It gave the machine a framework to evaluate symbolic logic. It allowed programs to be dynamic, which is, the foundational requirement for a machine to actually learn.
But to make Lisp work, he had to invent something else in 1959, something called garbage collection.
Yes.
Now, I have to push back here on behalf of the listener. You're making one of the greatest minds of the 20th century sound like a digital janitor.
I know the name isn't great.
Why is garbage collection considered a massive breakthrough?
Because memory in the 1950s wasn't just scarce, it was a severe physical constraint. Imagine you are cooking a massive, complex meal in a kitchen that only has 5 bowls.
Sounds stressful.
It was. In early programming, you had to write specific manual instructions to wash and put away every single bowl after using it, or you just run out of bowls.
Okay.
Programmers were basically memory accountants. They spent half their cognitive energy just managing the machine's plumbing, basically.
Which means they aren't spending that energy actually solving the high-level AI problem.
Exactly. So McCarthy invented an invisible sous chef. Garbage collection is this automated method of memory management that runs in the background. It constantly scans the computer's memory.
And cleans up the bowls.
Yep. The moment it detects a piece of data is no longer being used by the program, it just reclaims that memory space automatically. He took the cognitive load of resource management away from the human entirely.
So he automated the accounting so his programmers could do the philosophy.
Exactly. And because of that automation, Lisp became the programming language of choice for AI applications for decades. He made the tool so accessible that by the time he moved over to MIT to build their AI lab, his students affectionately just called him Uncle John.
That's amazing. Okay, so he's given developers the language to build AI. But the structural problem of the 1950s and 60s was access.
Huge problem.
Because you can write all the brilliant Lisp code you want, but computers back then were these massive room-sized mainframes. You had to sign up for a time slot just to run a single program.
It was a massive bottleneck for innovation. McCarthy realized that computing power shouldn't be limited by who physically had access to the terminal room.
Right.
So he became instrumental in creating early time-sharing systems at MIT, BBN, and Dartmouth.
And we shouldn't gloss over what time-sharing actually means conceptually, because it wasn't just about people politely taking turns.
No, not at all.
It was the virtualization of computing. The computer went from being a single, isolated physical object to a shared conceptual resource that multiple people could tap into simultaneously from different terminals.
He decoupled the hardware from the user interface, and that conceptual leap led to one of his most astonishing predictions.
Yes, here's where it gets really interesting. In 1961, during a speech celebrating MIT's centennial, McCarthy publicly suggested that this time-sharing technology could lead to a totally new economic model.
A utility model.
Exactly. He proposed that computing power, and even specific applications, could be sold through a utility business model. Just like you pay for water or electricity to be piped into your house, you would pay for computing power to be piped to your terminal.
Which is just wild to think about. He was describing AWS, cloud computing, software as a service, the App Store, all of it.
During the JFK administration.
Right. His colleague, Lester Ernest, explicitly stated that without McCarthy initiating time-sharing, the internet as we know it wouldn't have happened nearly as soon.
Wow.
But what is equally fascinating is how this relentless pursuit of testing and debugging systems started to bleed into his personal life.
How do you mean?
Well, McCarthy believed you could debug a computer program by testing it against reality. And by the late 1960s, he applied that exact same debugging process to his own deeply held political ideology.
Oh, right. Because he started out raised by deeply committed communists.
Yeah.
He was fluent in Russian, which actually allowed him to make genuine connections with Soviet scientists. In 1966, he even ran a famous computer chess match, where his Stanford team played against counterparts in the Soviet Union.
They lost 2 games and drew 2 games, actually.
Yeah, so he was deeply embedded in that international dialogue.
He was. But his relationship with the Soviet bloc completely fractured when it collided with empirical reality. In 1968, he visited Czechoslovakia shortly after the Soviet invasion.
Right.
He witnessed the suppression of the Prague Spring firsthand.
And witnessing that reality on the ground profoundly changed him. He didn't just, tweak his views. He fundamentally rewrote his internal code.
He really did.
Over time, he moved completely away from his parents' politics and became a conservative Republican. And regardless of where you fall on the political spectrum, this is just a remarkable example of his critical thinking.
Exactly. We're just looking at the mechanics of his mind.
Right. He tested his ideology against the real world, found it fundamentally lacking in his view, and changed his mind.
He applied rigorous, logic-driven analysis to human society. He became a vocal advocate for human material progress and an absolute, uncompromising defender of free speech.
Which played out online later on. In his later years, he was all over early internet forums, like Usenet.
Oh, yeah.
He actively defended the right to post European ethnic jokes on Stanford servers, arguing fiercely against any form of censorship. His philosophy on life was so deeply tied to mathematics and logic that his Usenet signature, which he also put a variation of on his car license plate, by the way.
I love this detail.
It read, "Do the arithmetic or be doomed to talk nonsense."
And doing the arithmetic wasn't just a catchy slogan for him. It was his fundamental philosophy for human consciousness itself.
Which brings us to the philosophical battleground of his career.
Yes. In 1979, McCarthy wrote an article titled Ascribing Mental Qualities to Machines.
Where he made a statement that ruffled a massive amount of philosophical feathers.
To put it mildly.
He wrote, "Machines as simple as thermostats can be said to have beliefs." Now hold on. A thermostat having a belief sounds completely absurd to anyone outside of a computer science lab.
It does sound crazy at first.
Right. Isn't a thermostat just a dumb mechanical switch? The metal expands when it gets hot, contracts when it gets cold. Where's the belief in expanding metal?
If we connect this to the bigger picture, it explains McCarthy's radical AI optimism perfectly. To McCarthy, a belief isn't some magical, ethereal feeling floating around in a soul.
Okay.
It's simply an informational state that leads to an action. The thermostat believes the room is too cold, and based strictly on that informational state, it takes the action of turning on the furnace.
Well, it's a binary state of knowing.
Exactly. And he argued that human beliefs operate on the exact same fundamental principle, just with infinitely more complex variables and feedback loops.
Wait, so he literally believed there's no magic in the human brain?
None.
Every single aspect of human intelligence, emotion, and intuition could theoretically be formalized precisely enough to be programmed into a machine.
Completely. He utterly rejected the idea of a spiritual or transcendent intuition. In fact, he declared himself an atheist in a speech right at Stanford Memorial Church.
Wow.
To him, the universe was an incredibly complex math problem, and humans were just biological computers slowly learning how to solve it.
I can imagine that mechanistic view of consciousness sparked some massive intellectual battle.
Oh, absolutely, because philosophers do not like being told they're just complicated thermostats.
I wouldn't think so.
His most famous rival was the philosopher John Searle. Searle fired back with his Chinese room argument in 1980, which is still one of the most famous thought experiments in cognitive science today.
Right.
Searle argued that machines can never have beliefs because they lack intentionality and actual understanding.
Okay, walk us through the Chinese room experiment. How did Searle try to dismantle McCarthy's logic?
Okay, so Searle said, imagine a person locked in a room who doesn't speak a single word of Chinese.
Okay, tracking.
Under the door, someone slips them questions written in Chinese characters. Now, the person in the room has a massive rule book. It basically says, if you see this shape, draw this other shape.
So they are just mashing shapes.
Exactly. The person follows the rules, draws the corresponding Chinese characters, and slips the paper back under the door. To the people outside, it looks like the room understands Chinese perfectly.
But the person inside doesn't understand a thing.
Right. They're just blindly manipulating symbols based on a manual. And Searle argued that this is all a computer is ever doing. It's just a syntax machine. It has no semantics, no meaning, and therefore no beliefs.
And so Searle is saying the machine is just a fancy calculator playing a matching game. It doesn't actually know anything.
That was his argument, yeah.
How did McCarthy counter that? Because that sounds like a pretty solid takedown of AI consciousness.
Well, McCarthy and other AI researchers used what's known as the system's reply. They argued that while the individual man in the room doesn't understand Chinese, the entire system, the man, plus the rulebook, plus the room, does understand Chinese.
Oh, interesting.
Yeah, it's just like how an individual neuron in your brain doesn't understand English, but the entire network of your brain
So
does.
the whole is greater than the parts.
Exactly. McCarthy maintained that if a system acts intelligently, it is intelligent. The substrate, whether it's biological neurons or silicon chips or a guy with a rule book, it just doesn't matter.
But Searle wasn't his only rival. There was also Hubert Dreyfus, right? A philosophy professor at Berkeley.
Yes.
And he attacked the problem from a completely different angle.
Dreyfus was a massive skeptic of early AI, and he fundamentally disagreed with McCarthy's premise that the world could be reduced to formal logic.
Okay.
Dreyfus came from the phenomenological tradition. He argued that human understanding is inherently embodied. It requires a physical body interacting with a physical world.
Meaning you can't just program a computer to understand human context because it doesn't actually experience human existence?
Precisely. Dreyfus argued that so much of our intelligence is tied to our deep existential reality. You know, our fear of death, our sense of vulnerability, our physical needs.
Right. The human condition.
Yeah. How can an AI truly understand a joke about falling down the stairs if it doesn't have a body that can feel pain?
That makes a lot of sense.
Dreyfus argued that without a body and a stake in the real world, AI would always hit a wall of common sense that it just couldn't compute. And they debated this fiercely for their entire careers.
So what does this all mean? Why does a debate between a computer scientist and some philosophers in the 1980s matter to you right now?
It matters more than ever.
Exactly. Consider a short story McCarthy actually wrote in 2001 called The Robot and the Baby.
Oh, that story is wild.
It was a farcical exploration of robots simulating human emotions. And in it, he eerily predicted massive aspects of modern internet culture, social networking, and the ethical dilemmas of relying on machines for emotional care, decades before they fully materialized.
He saw it all coming.
He really did. So whenever you open your phone today, interact with an AI, and catch yourself wondering for a split second if it actually understands you or if it feels anything, you are stepping right into the exact philosophical ring that John McCarthy built.
You're engaging in the thermostat debate. Are you looking at a deeply complex set of physical rules, or are you looking at a mind?
Right.
Are you talking to the room or the man with the rule book? McCarthy forced us to define what intelligence actually is.
To sum it all up, the scope of John McCarthy's life is just staggering.
Truly.
We are talking about a kid who started out reading translated Russian science books, who literally refused to do PE at Caltech because it offended his sense of logic.
And then took that uncompromising mind and coined the term artificial intelligence.
Created Lisp to give machines a way to learn.
Gave us the blueprint for cloud computing.
And fought tooth and nail for a completely logic-driven worldview.
It's crucial to remember that every single time you use a cloud-based app, or every time you hear a news report about the latest AI breakthrough, you aren't just experiencing random technological weather.
Right. It's on a storm.
No, you are living inside the architecture that John McCarthy envisioned, argued for, and actively started building over half a century ago.
And that brings us back to where we started. If he designed the blueprint for our current world, we have to ask ourselves, what happens when the house is finally finished?
That's the big question.
McCarthy believed that human intelligence was ultimately just formalizable logic, entirely programmable into a machine. So, as you watch modern AI confidently hallucinate facts today, ask yourself something.
What's that?
If McCarthy was right, and humans are just complex biological computers, our own cognitive biases, our misremembered childhoods, and our stubbornly held political views, just the human version of an AI hallucinating.
Oh, wow.
Maybe we're both just running flawed algorithms.
It's a question that requires us to do the arithmetic or be doomed to talk nonsense.
Thank you for joining us on this deep dive. Keep examining the blueprints, keep looking at the foundation, and most importantly, keep questioning the information around you. We'll catch you next time.